Welcome. Dear students, today we are going to discuss about Claisen condensation. When we discuss about Claisen condensation, do not confuse it with Claisen-Schmidt reaction. That is a different reaction and that we will look in a different video. Today we will focus on what is Claisen condensation. So there are 4 points in Claisen condensation. Number 1, it is shown by ester molecules. So which molecules show Claisen condensation? Ester molecule. Okay. It is two ester molecule. They self-add among themselves in the presence of a base. That is, self-addition of two ester molecule take place in presence of a base. Okay. Two ester molecule add themselves in presence of base. The third point is it is a condensation reaction. What is a condensation reaction? We know condensation reaction is addition reaction with the elimination of a small molecule. Okay, so mostly it is water which goes out. So it is a condensation reaction. Already we have said that it is a self-addition. We are again mentioning that it is addition with elimination of a simple molecule such as water. So third is a condensation reaction. The fourth point is that the product that is formed is a beta ketoester and an alcohol. So the product that is formed, mainly it is a beta keto ester. We are not concerned with the alcohol. So it is a beta keto ester. So these are the 4 points of Claisen condensation. Number 1, this is shown by ester molecules. Number 2, two ester molecules, they add among themselves in the presence of a base. Number 3, it is a condensation reaction. That is, again we are saying it is an addition reaction and a small molecule of water just goes out. The fourth point is that it is the product out of this reaction is a beta keto ester mainly, and an alcohol is also produced. So let us now see the reaction for this. I am going to take an ester molecule, okay, two ester molecules, and I am going to treat it with a base. As I have already said, it takes place in the presence of a base. Actually, base acts as a catalyst here. So the ester molecule that I am going to take is ethyl acetate. Okay, so I am going to draw ethyl first. Okay, this is ethyl. Okay, and then I am going to draw acetate. So what is acetate? This is acetate. Okay, ethyl acetate. Ethyl acetate. Okay, I'm going to draw two molecules. Okay, so rather than you can do like this, but for purpose of explanation I am going to repeat it here. Okay, so that we better understand the reaction. Okay, so two molecules of ester. Okay, ethyl acetate I have taken. I am going to react it with a very strong base. So the strong base that I am going to use is sodium ethoxide. Okay, so now we need to treat them with each other at 78 degrees Celsius for about 8 hours. Okay, and after doing that, go for acid hydrolysis 78 degrees Celsius for 8 hours, and then you go for acid hydrolysis. Okay, and the product that you will get is a beta keto ester and alcohol. Okay, so first I am going to draw alcohol. So what alcohol will I get from this? I will get, let us separate this. Okay, so the alcohol that I get, I'll write the alcohol first. C2H5OH. That's the alcohol that I will get, ethanol. Now you write this first and then you add it to this. Okay, so when you write this, how will you write it? CH3 C double bond O, you add to this one CH2 C double bond O C2H5. So now you form a beta keto ester. Okay, this is the ester, correct? This is the alpha carbon atom, this is the beta carbon atom, and ketone is at beta carbon. So beta keto ester, correct, and alcohol. So this is the easy way to remember this reaction. Draw two ester molecules, treat it with a very strong base and 78 degrees Celsius 8 hours, and then followed by acid hydrolysis. And how to draw? Take this, write one ethanol, and first you write this and then you add it with this. So you get a beta keto ester. This is alpha carbon, this is beta keto ester. Okay. Now let us understand the mechanism. So mechanism is, in simple, if you ask me mechanism in simple one sentence, I would say that the mechanism is nucleophilic addition of ester anion to carbonyl carbon. In simple one word I can say this, that this is the mechanism. Nucleophilic addition of ester anion to carbonyl carbon. Let us see the steps. There are 3 steps involved in the mechanism. Let us go for steps now. Step 1 is formation of ester anion. We have already mentioned in one line that ester anion is formed, formation of ester anion. Let's see how. What is the base that we have taken? C2H5, right, C2H5ONa, sodium ethoxide was the base that is taken. So Na goes, okay, C2H5O minus, which is the ester? Ethyl acetate, right? So that would be like this. This is the acetate and go for ethyl. Okay. Now for purpose of better understanding of mechanism, I draw like this. This is the same, right? I take an H out and draw like this. Now the ethoxide ion is such a strong base that it knocks out a hydrogen of this ester. So this actually knocks out this, and the pair of electron, hydrogen leaves its electron with this. So what you get is elimination of ethanol and formation of ester anion. So one of our product is formed which is not of major concern. Ethanol is formed and we have formed ester anion. That is the main thing. So that is a step number 1, formation of ester anion. Let us now go to step number 2. Now ester anion is formed. Now what the ester anion would do? Whether it will sit idle? Never. It will attack the other ester molecule at carbonyl carbon. So you can say step 2, nucleophilic addition of ester anion, to carbonyl carbon, Let's see. How. So for that, let us first draw the ester molecule. The ester molecule is ethyl acetate. So this is the ethyl and this is the acetate. Ethyl acetate is the ester. This is the second molecule of the ester that we are taking. Treat it with your ester anion. Ester anion is like this. Right? Now what would happen? You can see there is a significant difference of electronegativity between the carbon and oxygen, and ultimately this oxygen wins the electron and positive sign rests on carbon, right? So this adds, okay, to here. This is the nucleophile. So nucleophilic addition of ester anion takes place at the carbonyl carbon of the ester. Okay, so now what we get is draw this one, CO minus, take this and draw it at the bottom, OC2H5, and attach it here, CH2, C double bond, O, C2H5. So that is the second, that is the product of the second step that we get. Okay, so here what the product of the first step, that is ester anion, attacks the ester, second molecule of ester, at the carbonyl carbon. This is a nucleophile. Being a nucleophile, it attacks the positive carbon center and forms this. Step 3 is elimination of the ethoxide ion. Elimination of ethoxide ion. Elimination of ethoxide ion. Ethoxide ion by acid hydrolysis. Remember that we do acid hydrolysis. We have already mentioned that in our reaction. So you write this here. Write it here. OC2H5, and write this CH2, C double bond O, O, C2H5, right? You can rub this now. And now just react it with an acid, okay, acid hydrolysis, and what the acid would do, it would take C2H5OH with its pair of electron. So you get C2H5OH, right? And this automatically comes here, and what you get is a, right, we got our product beta keto ester. That's a beta keto ester. Dear students, we have seen that Claisen condensation is used in the preparation of beta keto esters. It can also be used in the synthesis of alkyl ketones. If you have understood the class and if you have liked the class, please do subscribe the channel. Thank you very much.